Hello, everyone. All right, let's try this. So this is going to be the first question in the Chapter 9 worksheet. So if you got the Chapter 9 worksheet from Canvas, you can go ahead and take a look at it. So in brief, it's a personal control questionnaire measures people's sense of control that they have over the events in their lives. The mean score of the college students is 51. So we're given a mean. All right, so we're already given a mean. So we're probably thinking one sample t-test because we're already given a mean so far. So what do you think about students who are in academic difficulty? So the average student has got a 51, but what about students in academic difficulty? Suppose you gave the PC questionnaire to 12 students who are in academic difficulty. Perform a t-test, calculate the effect size index, and write a conclusion about the academic difficulty and PC scores. Degrees of freedom equals 11, and your S sub x bar equals 2.361. All right, so what you need to understand is that you're dealing with a t-test here, a one sample t-test, because you have one sample, you're going to calculate an average, and then you're going to compare it to something that's already sort of given. So what do we have that's given? So we know that mu is what they're claiming is 51. And what you need to do is you see there's 12 scores right there. So what you need to do is add them all up and divide by 12. And so your sample, you end up getting an average of, let's see, what is the average? 45. So you add them all up, divide by 12, you get an average of 45. So we already know the S sub x bar was given to us, a 2.361, and we've got degrees of freedom equals 11. So what is it that we need here? Well, if we're doing a one sample t-test, we need our t-value. We need to calculate a t-value. So how do we get our t-value? Well, we get our t-value by taking x, our sample, over what was claimed the population, all over S sub x bar. So what do we got going on here? So for that, we got 45 minus 51 divided by 2.361. So what do we end up getting there? We end up getting a negative 254,129. So if you follow that whole process right there, we end up getting our t-value is this. So this is our t obtained. So we have a t obtained value of that. Okay, great. So what does that really mean? So now we end up knowing in essence, what we're doing with all this is we're trying to find out if our t is in the designated rejection region. So we've got our t-value here. We got our negative 2.5. So we're going to be over here. But we need to find out what our critical t-value is from the t-distribution. So how do we do that? Well, we got to go back into the t-distribution, the back of our book. So again, it's going to be Appendix C, Table D. And we know we've got degrees of freedom. Oh man, this is really blurry. So we got degrees of freedom of 11. And we're going to go over, and if we're not given any sort of information, we just assume our confidence, our alpha level is going to be an 0.5 with a two-tail test. So if we're not given any more information, if we're not told we're going to use a different p-value, if we're not told we're dealing with a one-tail test or not, you just assume 0.5 two-tail test to begin with. So we've got 11 degrees of freedom. We go to an alpha level of an 0.5, a two-tail test. We get our critical 2.201. So what does that mean? That means our critical 2.201 negative, positive. So what does this mean? This means we just created our rejection region. So any score that falls on either side of that, we're going to reject the null. So now we go back to our other t value right here. We got a negative 2.5. Well, our negative 2.5 would be over here, right? Negative 2.5. That's more extreme. Again, this is the more extreme, the bigger numbers you get, the more you go in either the tail direction. So right now, our negative 2.5 is in our rejection region. So what should you do there? Well, if we're looking at our worksheet, our t-value is what we want, that very first one. Here's the answer to our t-value, negative 25412. Our critical value is this. We looked this up, 2.201. What do? Well, if we're in the rejection region, if we're more extreme, what do? We reject the null. Okay, great. Awesome, we get to reject the null. And what does that really mean that we reject the null? That means that this average that we got is significantly different from what they're claiming that the average is. In this particular situation, again, it's better to try to have an example here. So the example here is that we're talking about all college students. I think it's college students, right? College students. Average college student gave us a 51, but is our population, our unique population, our sample size, our academic difficulty students, are they different from the average? Well, this is what it's telling us, is that it's yes, that our students, the population, the subpopulation of students who are in academic difficulty, they are significantly different from the average college student at a 51. All right, so now what do we got? We got to do an effect size index. So this is where it starts getting a little crazy. So the effect size index, we got to find the difference between what we've been talking about. So this is our D. So we've got our average here, 45 minus 51. But then we got, what is this going on here? S sub hat. Well, that's not what this is. So we got to do a little bit of back solving. And so our back solving puts us at S sub x bar is equal to S hat divided by the square root of n. So we might have to do a little back solving. So we got to isolate this. So we've got this number, 2.361. And so now we're solving for this. And our square root of n, what was our n? Our n was 12. So we need the square root of 12. So what we end up needing to do is we multiply whatever that square root of 12 is by 2.36, and we get this number. And if you do the equation, you end up getting 8. We can round this. You end up getting 8.180. So again, this is just a math. So take the square root of 12, whatever that is, multiply it by 2.36, then you get that 8.18. So now we use that into our equation over here. We do the equation, we end up getting an effect size of 7.334. So we got to remember what it is we're talking about here with effect sizes for a D. So effect sizes between averages is 0.2, 0.5, 0.8. So this would be between a medium to large effect. So at that point, we're filling this out. We got the t-value, we got the critical t-value, we're rejecting, we got the effect size index, what size of effective is this? We say it's medium to large. And so we got this final conclusion. What this final written conclusion needs to be is relating it back in actual words. All right, so what do we got going on here? We got a subsample of students with an academic difficulty, and we've got an average of college students of 51. So what can we say? We can say students experiencing academic difficulty, we say students experiencing academic difficulty, parentheses, an average of 45. You want to write that in there. So students experiencing academic difficulty, parentheses, we got an average here, X bar, display significantly lower. So I want to say lower. You want to tell me which the direction is. So again, 45 is significantly lower than what our average was here. So again, that's the Z, but our average here was a 51, or over here, it's a 45. Significantly lower PC scores compared to average college students. And you want to tell me what that average is too. And their average is 51. And you got to tell me P is less than what? P is less than 0.5. So this final thing is we need to find out how far we can go lower. So if we go back into our textbook, again, this is probably just a little bit some extra stuff that we really need to understand here. So if we've got degrees of freedom of 11, and we've got this 2.201, all right, so that's that alpha level of a two-tailed test of 0.5. I kind of want to see what the critical value is for 0.1 and 001. So I want to know how far I can go. So the critical value for an 001 would be 3. 3.106. And then if I wanted to keep going, I end up with a 4.4. So I'm obviously not that far away because I'm only at a 2.5. So if I had a 3.2 here, I can say P is less than 0.1, but I can't because I only got a 2.5 right now. If I had a 4.6, that would be way over here. I could say P is less than 0.001. So what I need you to understand is that you look at these critical T values. Typically, the critical T values we're looking for are the 0.5, the 0.1, and the 0.01. So if you go down the critical for here, for our situation, it's 2.2, 3.1, 4.4. We can only reject this far. We cannot reject this far. So when it comes time for how you explain your conclusion, your written part of your conclusion, tell me how far you can go on this p-value. And again, next example, I'll show you that even more so. All right, let's hope this works. Thanks.